In the previous video, we looked at the graph of the natural exponential function e to the x. And so what we can do is we can transform that function just using our rules of transformation. And so in these examples, what we're going to do is we are going to graph the transformed function based on the parent function e to the x, and then we'll give the domain range and any equations of the asymptotes. So our first function that we have is this e to the x minus 2. Notice that the minus 2 is in the exponent, which means that it's really the function composed of x minus 2. So in reality, it looks like this, f at x minus 2. And that transformation means that we are going to move right 2. Okay, so we're going to take and move the graph right 2 units. The domain of every exponential function from negative infinity to positive infinity. So that's easy enough. Range of this function. Notice that we did not vertically translate this function. All right, so because there's no vertical transformation, the range is going to be from 0 to infinity. And then finally, the asymptote, because again, we didn't have any vertical transformation, is y equals 0. Now, if I want to graph this, remember we had our one stationary point, we had this 1, 0, or 0, 1, excuse me. And so what we're going to do is we're just going to move that point 2 units to the right. And this is like our stationary point. And this is the point where this function starts getting really big really quickly. It's still asymptotic to the x-axis. And so if I was to guess what this function would look like, just trying to get a visual of it, that's about what I would guess. If we go back into our graphing calculator and we graph y equals e to the quantity, make sure you put in parentheses x minus 2, and we would plot the point 2 comma 0, or sorry, 2 comma 1, it would fall precisely on the graph. All right, so that's a way that we can check to make sure that we've done the transformation correctly. Looking back at your graph, this point 2, 1 should be on the graph of the function using the technology. A second example, e to the x plus 3. Now, this one looks more like f of x plus 3, okay? And so the transformation is a vertical one, and we're going to move up 3 units. Domain, always easy for an exponential function, negative to positive infinity. We did a vertical transformation, all right? So the range is going to move up 3 units. So instead of from 0 to infinity, it is now from 3 to infinity. And then finally, the asymptote of this function is going to be at y equals 3 because we shifted everything up 3 units. A basic graph of this. So usually we would have this stationary point, but we're moving up 3 units. Right? So here, and then at y equals 3 is going to be our asymptote. And so if I was to get a rough estimate as to what e to the x minus 3 would look like, it might look like that. If we graph it, so we have e to the x plus 3, excuse me, we should have the point 0, 4 on the graph. And I think we can clearly see that from the graph. The asymptote should be at line y equals 3. It certainly looks like that it fits what we suggested that the graph might be. Okay. All right. This example, or this problem, we go through and we implement both a vertical as well as a horizontal transformation. So the way I think about this looks like f at x plus 1 minus 4. And so what we're going to do is we're going to move left 1 unit because of the x plus 1, and then we're going to move down 4 units because of the negative 4. Domain always the same for an exponential function. The range, we move down 4. So instead of 0 to infinity, it's going to be from negative 4 to infinity, exclusive of 4. And again, because we move down 4, the asymptote is now at y equals negative 4. Right? So we usually have this one stationary point, okay? That's going to be 0, 1. We're going to move down 4. So we're going to move down 1, 2, 3, 4. And then we're going to move left 1. So this is where our stationary point is at this point, right? And here's going to be our asymptote. And so if I was just to draw a rough sketch of what this looks like, probably something like this. Okay, and that's all we're trying to do is we're just trying to get a visual in our minds as to what this function looks like. Okay, going back up to the graphing calculator, we have e to the x plus 1 minus 4. I'm going to shift the graph around a little bit. Remember, we looked and we saw the point -1, 3, or I'm sorry, -3 on the graph, and that fits on there. And we had the asymptote y equals -4. All right, so that looks like everything fits well with what we suggested. Okay, so this graph looks approximately what we have here. Now we're going to have some reflections. So now we have the e to the -x minus 3 plus 1. Right? If I was to try to think about what this transformation would look like, maybe f at x, -x minus 3 plus 1. And so we have three transformations. Right? So the first transformation is we are going to move right 3. The second one, we're going to move up 1. And the negative inside the parentheses is going to suggest that we reflect within the y-axis. Okay, so we're going to reflect in the y-axis. All right. So domain, easy, all real numbers. Range, we moved up 1. So it's going to be from 1 to infinity. Asymptote y equals 1 because we moved up 1. All right, so here's the way that I think about this. All right, so here's our graph. All right, the y equals 1, the asymptote is fixed. There's nothing we can do about that. All right, so we'll draw that in a second. This is our stationary point. We're moving right 3, and we're moving up 1 unit. Okay, so this is where the point would be, but we're reflecting it in the y-axis. Okay, so what we're doing is we're just moving it 3 over here. And this is going to be that point where the function starts to rise pretty quickly. Okay. Now, again, we are reflecting this in the y-axis, right? So let me get rid of these. We have our asymptote. Right? And so what we're going to do is we're going to draw it this way this time. Whoop. Let me try that again. Right. So drawing this way. There we go. That's about as good as it's going to get. All right. I'll just make the dot bigger, just like when I was in 7th grade. All right. And then, of course, we want to check this by using our graphing device. So we have e to the -x minus 3, and then plus 1. I believe that we had the point -1, 2 on our graph, or -1, 3, or -3, comma 2 on the graph, and our asymptote was y equals 1. All right, so it looks perfectly what we suggested as to what it looks like. So again, when we flip it in the y-axis, that means we're just reflecting our shape and we're just reversing it. Okay, so we're just kind of spinning it around this way, if you would. All right. All right. Now the last one we have, we're going to have a reflection in the x-axis. All right, or supposedly. All right. So we have this negative e to the x minus 4 minus 2. And so our transformations, if I think about this, this is going to be f of x minus 4, negative on the outside, minus 2. So 3 transformations. We're going to move right 4 units. We're going to move down 2 units. And we're going to reflect in the x-axis. All right. Now, technically, what we're going to be doing is we're going to be reflecting in the asymptote. Okay. So what we're going to do instead is we're going to reflect once we get the asymptote. Okay, so we'll figure that out. The domain, easy, negative infinity to positive infinity for e. Range, since it's minus 2, it's going to be from -2 to infinity. All right. Actually, because we're reflecting in that axis, excuse me, it's going to be from negative infinity to -2. And the asymptote is going to be -2. All right. So we're going to reflect in the line y equals -2 when we do this, right? And we're moving down 2 units, okay? So let's go ahead and graph this. All right, so here's our graph, all right? Again, we have y equals -2. We usually have the point 0, 1, but what we're doing is we're moving right 4 and we're moving down 2 units. Okay, so that's going to be right here for our usual point, but what we're doing is we're reflecting it. So we should have the point right here. Okay, and usually we have a shape that looks something like this. Okay, so if we reflect it in the axis, what's going to happen is it's going to look something like this. All right. Now, let's keep this point in mind that we have the point 4 comma -3. All right, so let's see if that point manifests itself on the reflected graph. All right, so we have our graphing calculator. So we have -e to the x -3 -2. All right, and we have the point 4 comma -3. All right. Looks like that point is not on there. So that's not good. Unless I didn't move far enough. So that's right 4, right 2. Down 2. 4 comma -3. Let's see if I just made a mistake. 4 comma -5. Nope, that's not on there either. And we certainly don't have the point. Well, we have our axis, which is y equals -2. All right, so that certainly looks like it works well. And we had the point. Oh, that's what I did. I put that in incorrectly. So this should now work. So we should have the point 4 comma -3. All right, there we go. Okay, so apologies. Just typed it in wrong. All right, just a lesson that we should be careful that we typed in the original problem correctly. All right, so that's all of our transformations. And hopefully this is not too bad for everybody with respect to the natural exponential function. So in the next set of videos, what we're going to do is we're going to start taking a look at the inverse of exponential functions. We're going to start taking a look at logarithms.